Hi, everybody. Today I want to talk to you about sighting. And sighting is actually one of the most important things that an artist can do to get better at drawing from life. And sighting is how artists measure the objects that they see in front of them and how they use measurements and ratios to then translate the forms and the dimensions of those forms onto their two-dimensional surface, onto their picture plane, like their paper or a canvas, etc. Today we're going to start with one object and we'll go into something a little bit more complicated in the next video. But first I want to show you how to sight. Now there's a couple of things. One, I'm filming this and the camera only uses one view while your eyes have two different views. You have binocular vision, which means that you can see in 3D, while the camera can only see in 2D. So in order for us to translate a three-dimensional object onto a two-dimensional surface, we actually want to be able to see two-dimensionally. And therefore, we're going to close one eye when we use sighting from objects that we're looking at. And you can test out which eye is your dominant eye. One will feel more comfortable than the other when you close it. And again, that's so that we diminish our binocular vision and therefore can see in 2D. Now, the camera already sees in 2D for us, but I just want you to know that when you're looking at this object in real life, you need to close one eye. The other way that we use sighting is we'll be using our pencil and we're going to extend our arm fully. So we're going to extend it all the way out. And that's so that our measurements are consistent every time. If I have a little kink in my elbow, the measurement that I take is going to get bigger or smaller depending on if I'm closer or further away from the object, as well as my view closer to my eyes. And so by extending our arm all the way, that measurement can be consistent, can be the same every time. So it's really important to extend your arm all the way and not have a kink in the elbow. So let's just get started. I'm going to show you guys how to sight, and again, I'll be doing it for the camera specifically. So as we're sighting, I'm using a single object here, a little bottle. I actually filled it with some white liquid so that it has a nice contrast with this black background. And the first thing we're thinking about is we want to make comparisons between its height, its width, and then all the elements of it. Its bottle cap, the neck of the bottle, the width of the bottle here, how it's starting to curve, its width in the middle, etc. And I will first show you guys how to sight, and then I will do a drawing. I'll zoom out a little bit and do a drawing for you. So the first thing that you need to do when you're sighting is you need to choose a ratio, choose a measurement that's going to be kind of your measurement of one. It's going to be the measurement that you use over and over again to measure anything in the composition, and you will always use that same measurement. You're never going to change it, and it's so that everything else in the drawing can be consistent. In this object, I think that the width of the bottle is actually a really good measurement. And the way that we sight is we will put the tip of our pencil on the edge of one object, and we'll put the thumb on the edge of the other part of the object that we're holding. So basically, we are going to make ratios and create comparisons that are something like this. What is the width of the neck compared to the height of the bottle? So how many times does the measurement of the width of the neck go into the height of the entire bottle? And we can, again, hold that measurement and measure horizontally or vertically. And I'll do that once and I'll talk a little bit about why we only work horizontally and vertically. So the width of the bottle is going to go into the height of the bottle. 1, 2, 3, and about a half. So this bottle is 3.5 neck widths tall. And then we can do it the other way too. We can say, what is the width of the bottle compared to the width of this bigger base of the bottle? And that's going to be 1 and about 2/3. So 1 2/3. So let's do that again, just so you guys can see it. Width of the neck compared to the width of the bottle, and you can see how many times the rest of that goes into my pencil. It's not directly to my thumb, it's just a little bit less, and I can think about that if I break up this measurement of my pencil into three, 1, 2, and to my thumb 3, that would be about 2/3. And that is how we're going to use sighting. And we're going to break up this object into its different parts. So for example, we're going to take the width of the bottle and we're going to say, how many times does the width of the bottle go into what we see of the height of the bottle cap? And that's everything that I see in white. And you can see that that measurement is just under 1. And we can also think, well, how does the circular part of the bottle cap compare to the side of the bottle cap? And we can think about that. That's about the height of the bottle cap that's circular here is just a little bit bigger than what we see as that height of the side of the bottle cap, and we can think about how that falls into our pencil. We'll also take the width of the bottle and say, how many times does the width of the bottle go into the neck of the bottle? And that's about a 1-to-1 ratio, maybe just a little bit under 1. And then how many times does the width of the bottle go into this curved part, the part of the bottle that starts to curve out? And that's about a measurement of 1. And then how many times does the width of the bottle go into the rest of this space? And it's about 1.5, or maybe just a little bit less than half for this whole section of the bottle as well. And we will draw each one of those sections separately. The other thing that I just want to mention is we sight vertically and horizontally. We don't sight at an angle. And it's because an angle is really difficult to reproduce. So if I want to hold my pencil at this angle and then bring it down to my paper, it's really difficult to know whether I have that angle correct. Instead of doing that, we'll actually look at angles in comparison to a vertical or horizontal line. So if I hold my pencil here, I can actually see this space, this negative space of the bottle better. And I can start to draw that shape and think about at what degree I see this angle. But I'm going to use my pencil horizontal or vertically. And then I'm also going to use my pencil horizontally to look at the spaces between the object here, the negative space under the object, to see how things are sloping away from a vertical or horizontal line. So I will always use a horizontal line, a vertical line. We'll think about center lines. And again, we'll use sighting to measure that space, but we will never hold our pencil like this at an angle. All right, in the next section of this, I'll be drawing this bottle and talking you through each step. Hi, everyone. So now I'm going to show you how to use sighting and draw on your paper. So the first thing that we need to do actually has nothing to do with the bottle itself. So we need to make a decision on how big we want the bottle to be on our picture plane. And that can be any size we want. We might want a bottle that's small. We might want a bottle that's big. In this case, I actually want a big bottle. So I actually want to mark that I want the top of my bottle to be here. This is a symmetric object. In fact, if we start to think about what this object is made up of, it's really made up of mostly cylinders. So the base of the bottle here is a cylinder, the neck is a cylinder, and then even this bottle cap is actually a cylinder. There's a cone-like shape here where the neck is, but the rest of these objects are cylinders. And what we know about cylinders is they're symmetric. So I'm going to actually give myself the center line for this object, because it's going to show me and help me get the correct symmetry from one side to the other to create something that actually looks like a mirrored object. And we don't need to be super concerned about our lines here. If they're just a little bit askew, that's okay. I'm going to actually try to move my camera so you can see my line pretty well. One second, here we go. So I want to decide how big the object is going to be on my paper. And that's going to be a decision that I make without any information from the subject itself or the object itself. Really, the question is, how do I want things to fit on my paper? And that's the first thing that we're going to do. And now this will give me the height of this object. So now I know how tall I want this object to be, but I don't know any other information. I also want to choose that measurement of 1 that I'm going to use to cite everything else in this composition. And I want to choose something that fits into the height of the object, something like 3 or 4 times, maybe 5 tops. If I choose something that's really small, it might be really tedious to cite with. So what I was going to use is the width of the bottle. It's really clear for me to see. I know exactly where the edges of it are. There aren't any like hidden edges. Unlike, for example, the height of the neck of that bottle, it's really kind of confusing right in this area. And so I might start citing, and I might cite and decide that I'm going to cite from here. And next time I come back, I might start to cite from here. And even that little difference can actually make a difference in how the ratio of the drawing ends up. I also don't want to choose something that's super small. So for example, if I decide that I want to choose the the height of the bottle cap here, and then I start to take that measurement into the height of the bottle, let's see what happens. That's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, all of a sudden that feels really tedious to measure that many times and to keep track of that ratios that are like 1 and 9. So instead, I want to choose something like the neck that is going to go into the height of the bottle 1, 2, 3, 4, and just a little bit times. So let's talk about how to do that. So the bottle itself is 4 and a little bit. So how in the world do I translate that into this vertical line that I've just created? Well, the easiest way is to be really kind to yourself and try to make these ratios as simple as possible. So I know that the majority of that height is 4. And the easiest way to get 4 is to take this line and divide it in half. You always want to check your work, and our pencil is I'm going to just switch hands so you guys can see it, is a really easy way for us to check our work. Put the top of your pencil on one side, your thumb on the mark that you just made, and compare it to the mark that you just made under here, and they actually seem pretty even to me, but it's really good for you to check your work. I'm also working at a little bit of an angle, so just take that into consideration that the view might be a little bit skewed. So I broke these up into half, so now I have 2 equal parts, and then I'm going to break these up into half again. And again, I'm going to check my work, making sure that that these sections are all the same size, so that I now have this measurement broken up into fourths, 1, 2, 3, 4. And we decided that the width of the bottle neck went into the height of the bottle 4 and a little bit. And so I'm going to just add that little bit onto the bottom here, giving myself the bottom of that bottle and the top of that bottle. And I'm going to extend myself some lines. We're going to use organizational line for this, giving myself the horizontal lines that are going to correspond with the bottom and top of my object, my center line, the edges of my bottle, etc. So now that I have that, I want to start comparing and getting the width of the bottle. I now have the height. So I'm going to take the width of the bottle neck, and I'm going to just say, is that the same as the height of the, or is that the same as the width of the bottle itself? And the answer is yes. So they are the same size. The neck and the bottle top are the same size. And I already have that measurement of 1 because I took the neck of that bottle and I compared it to the height of the bottle, and it was 4. So one of these fourths is actually going to be the same size as uh, the neck of the bottle or the top of the bottle. They're going to actually be the same ratio. So I know that the neck of my bottle is somewhere in here. And again, it's okay if your lines are precise. I don't want you to use a ruler for this. I want you to eyeball all of these measurements. So now I know the width of the bottle neck. What I need to know now is how long do I take this measurement down? So how long does this width continue to here in terms of the height of the bottle neck? So I'm going to take the width of the bottleneck and compare it to the height of the bottleneck, everything I see in terms of the bottle cap and below. So that's 1 and about 1.5, because if you can see, like, that neck of the bottle hits my pencil right about here. So that was 1 and about 1/2. So this is 1, this is 1. So to about here, 1.5 is where my bottle neck is going to go down to. And then past this, I have some curves here that we'll talk about in a second that I know are somewhere in this space. But now I also want to take a measurement and say, okay, we got the bottle to here. So what is the height of the rest of this measurement? I'm just going to double check my work and make sure that this is still the same size, and I've drawn that correctly. So that was the width of the bottle neck, 1, 2, 3, and a little bit. And let's see if that's still what I have. 1, 2. I feel like it needs to be just a little bit. Hold on, let me check that again, because you have to check your work all the time with this. 1, 2 and a half. So that's 1, 2. We're pretty close. So then let's figure out what is the width of this part of the bottle. So if I take the neck of the bottle and I compare it to the width of the bottle, that's 1. And it almost looks like 2, but I don't think it is. 1. Yeah, I actually think that it is twice that. 1, 2. So this measurement, or a measurement of 1, is going to go out from that center line, 1 on each side. And I keep dropping my pencil here. Here we go. So it's going to be 1 of those measurements on each side. So now I have the general shape of that bottle, and I also know that something's going to happen here in the neck section. So I know that that's not quite right yet. So now let's take it a little bit further. Let's measure out how much we see in terms of the cap, how tall that is, and when this transition between the neck and the curve or the angle here happens, and then how much this little part on the bottom is. So we'll do all 3 of those. So we're going to take the width of the bottleneck and compare it to the cap. And I say that it's about 2/3. So if I look at this measurement, which is 1, if I were to break it up into thirds, that 2/3 line is going to be everything I see in terms of that bottle cap. Now let's go into what I see in terms of the neck. So, or that part of the neck that starts to slope downward. So the width of the neck compared to this section is 1. So I'm going to, again, take that measurement of 1. However, I want to take it the width of the bottleneck. I'm going to mark myself where that bottle transition. So there's this, look quite right, but there's something I think not correct yet here on the bottom of my bottle, but we'll keep working on it. We'll keep fixing it. I think that my measurement here just needs to be a little bit longer. So I know that there's going to be a curvature change here, and I'm going to just check my work one more time, see where I'm, yeah. And then let's take this measurement one more time. I feel like it's playing tricks on me a little bit. 1 and what do you think? 2/3. So if this is 1 and 2/3 would be around here. So I'm going to extend the bottom of my bottle because I think that it's just a little bit longer. And I'm so glad that I can show you guys that, because there's going to be times in your drawing where you just feel like something isn't quite right, and I want you to keep checking your work and keep making corrections. So now this height of the bottom of the bottle actually feels much more correct. And let's figure out what this measurement is. So I'm going to take the height of the width of the bottleneck and compare it to the little bottom here. And I would say it's a little bit less than 1/3, probably 1/4. And so I think that that's going to be about here, that little section kind of transitions. The other thing that we can do before we start thinking about angles is figure out how big is this compared to this. So we could, take the width of our bottleneck and just take a look how many times does that measurement go into that bottle cap. But when we get into a slightly smaller angle like that, or ratio like that, we can't compare one section to the other. So I can take the height of that bottle cap and compare it to the height of everything I see in white above it, that ellipse on the top. And it does look like they're the same. So this measurement here, if I were to break that up in half, this section is going to be the ellipse of the top of that bottle, and then the rest is going to be the shaft of that bottle cap. So our bottle's starting to look quite geometric, but our ratios are starting to be translated. They feel like they're going to be correct. So here are some things to start doing once you're at a point where you've gotten all of your vertical and horizontal measurements, all of your height and all of your width. Now you usually get to a point where you have diagonals. And here's what I want you to do. I want you to hold your pencil vertically. You're not sighting at this point. You're actually looking at negative space. So if you hold your pencil vertically at the edge of that bottle, I'm going to grab one more pencil to show you guys. I want you to look at this space. So if you look at this space, it kind of looks like, I don't know what it looks like. Sometimes, I guess it looks like a quill pen to me or something, just a trapezoid that kind of turns into a triangle here. And I want you to think about what is the shape that you see. And if you were to think about a clock, so if you're imagining a clock here, and this, the pencil is pointing at 12 o'clock, at what angle do you see this diagonal? And for me, if this is 9 o'clock, this is probably pointing closer to 11. And I know that this is about where that angle is going to start. So this angle is going to start about here on my paper, and it's going to connect here at the edge of the bottle. And if I think about that as being at around 11 o'clock, again, if you imagine a clock face here, and we had put our pencil with the edge of the bottle here, like our pencil was here, we were looking at this negative space, and we're looking at this angle. So one, we can capture that angle, and then two, we can start to further refine and think about, what does that negative space actually look like? Where does that bottle start to have just a little bit of a curvature? And we can refine that form. The other thing we can do is go on the other side and kind of do the exact same thing. We're going to look at this space again, that negative space. Then we're going to look at this diagonal and think about what a clock that's pointing. And it's pointing probably closer to 1 o'clock on that side. And same thing, if I think about that my pencil is on this side, what does that angle look like? It doesn't, for me, like there's this little part that kind of goes out, and so that angle doesn't start right at this line. If you hold your pencil to that line horizontally, it doesn't start right at that line. It's right above it, or it's a little bit above it. And then when I look at the bottle itself and think about that negative space, there's a little indentation, there's the neck of the bottle, and then it curves in a little bit and then goes to the edge. The other thing that I want to make sure is that the two sides of my bottle are symmetric, that they're mirror images of each other, because otherwise it will look really funny. So making sure that whatever's happening on this side and this side is the same. That's why that center line is really important for us to see. All right, let's look at, I'm going to zoom out just a little bit so we can see this. So let's look at the bottom of the bottle. So right now, the bottom of my bottle is a horizontal line. And of course, that's not correct. This bottom is not flat. It's not like the top of my paper here. Instead, it's actually a circle. I know that the bottom of this bottle is actually a circle. And so a circle in perspective is an ellipse. And I don't see the full ellipse. I see the curvature at the bottom of the bottle, and I know that if it was transparent, I would see that ellipse going all the way through. But I only see the front edge of that at the moment. And for me to understand this curvature, I can actually break it down and use some really simple geometry to figure it out. If I hold my pencil horizontally at the bottom of this, I start to see these two triangles, one on this side, if you see this little triangle, and this little triangle, sticking out up from my pencil. And if I start to think about and see those as triangles, it's easy for me to start to think about, at what angle do I see these coming up? And let's go back to our clock analogy. So my pencil is pointing at 9 and at 3. So I can think, well, what angle is that sticking up and pointing to? And I would say that that's, I don't know, probably at about 10 o'clock. And on the other side, on this side, it's about 10. And on this side, if this is at 3, it's probably, I don't know, somewhere, I guess it would be at 1 if I say that this is a 10, but something close to that. So if I can imagine that my pencil was here, and I can think, well, at what angle do I see these parts of my bottle sticking up? And if I start to think about seeing this space, this negative space underneath the bottle, and then once I have those, I can actually curve this into the curvature that I see here. So I can start to curve those lines into what I see while first starting with those simple geometric forms. So then we can also do something similar with a bottle cap. We can think about at what angle do we see that bottle cap sloping. But there's something else that we can also do with the bottle cap that we will talk a little bit further in terms of ellipses. But when we are thinking about an ellipse is symmetric. And so one of the mistakes that students make is that they'll create an ellipse. I made my ellipse too good. Here we go. Here's a bad ellipse. So they'll make an ellipse that looks something like this. And if you think about it, it's not symmetric from the upper side to the bottom side. And if we cut it in half this way, this side is much thicker than this one. And we actually want something that's going to, if reflected with a mirror down, would be the same. And if we reflected with a mirror over, would be the same. So it's symmetric on both sides. So the easiest way to do that with a symmetric object, mostly if you know its height and you know, its height and its width, is if you were to place a cross right inside of that form. This is where the top of the lid is going to be. And if I break the height in half and break the width in half, and then I paying attention to where those halves are, those are going to be the top axis of our ellipse. I can start at that very top axis and slowly curve my way down to the left-hand side, and then slowly curve my way to the bottom. And same thing to the right and back, just making sure that they're really symmetric. All of a sudden, I can have a nice symmetrical form there. I changed my view a little bit of the camera. 1 second. So the top of that bottle cap doesn't get squished or changed on one edge or the other. And I know that the bottle cap is this tall. And then the other thing that I know is that the same angle that I see here, the curvature that I see here for the top of the lid, is going to actually be mimicked here on the bottom. So I can also look at the curvature that I've drawn here and then repeat it as best as I can on the bottom here, so that this curve and this curve will look the same. So those are the basics of sighting: using our pencil to measure, using our pencil to create ratios, and then breaking the form apart by thinking about center lines, the width, the height, and all the areas in between, using negative space and vertical lines and looking at negative space to determine angles, and then using our pencil horizontally to determine angles at the bottom of that bottle. I'm just going to come up and over so that you can see what the drawing ended up looking like. And there's a lot more that I could still do to refine this drawing and make it look even more like that bottle. But those are the beginning ideas that I want you to understand and start to practice. So this is how you deal with one object, and in the next video I show you how to deal with multiple objects.